When dealing with Autovolt appliances that can operate on both 115 volts and 230 volts, proper grounding is paramount, especially after modifications to your electrical system. If an electrician previously connected your appliance to a 115 volt supply using one hot wire and a neutral, and you've since separated the grounding of the appliance's frame, it's crucial to re-establish a secure ground connection. The primary reason for grounding any electrical appliance is to provide a safe path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock hazards. Firstly, you must ensure that the power to the appliance is completely turned off at the breaker panel. This is an essential safety measure to prevent any risk of electrical shock while working with the wiring. Locate the breaker that supplies power to the circuit in question and switch it to the OFF position. It's also a good practice to test the circuit with a non-contact voltage tester to confirm that the power is indeed off before proceeding. Secondly, identify the ground wire of the appliance. This wire is typically green or bare copper, distinguishing it from the hot usually black or red and neutral usually white wires. The ground wire might be connected to the appliance's chassis or frame. Thirdly, carefully examine the existing wiring and connections to ensure that they are in good condition. Look for any signs of damage such as frayed insulation, loose connections, or corrosion. If you find any issues, address them before proceeding with the grounding process. Fourthly, connect the appliance's ground wire to the grounding system of your home. There are several ways to achieve this, depending on your home's electrical setup. Connecting to a grounding rod. If you have a dedicated grounding rod, typically located outside near your electrical service panel, run a ground wire from the appliance to the grounding rod, ensuring a secure connection using appropriate grounding clamps or connectors. Burying the grounding rod should be buried deep enough to reach moist soil for effective grounding. Check local electrical codes for specific depth requirements. Connecting to the cold water pipe. In some cases, the metal cold water pipe entering your home can be used as a grounding electrode. Connect the appliance's ground wire to the cold water pipe using a grounding clamp. Ensure that the connection is made as close as possible to the point where the water pipe enters your home. Jumper cables around insulators. If there are any insulators or non-conductive sections in the water pipe, install jumper cables around them to maintain continuity of the grounding path. Connecting to the grounding busbar inside your electrical service panel, there is a grounding busbar. This is a metal bar where all the ground wires in your home converge. Run the appliance's ground wire to the grounding busbar and securely connect it using a screw terminal or other appropriate connector. Verify your grounding system. Ensure that the grounding busbar is properly connected to the main grounding electrode system of your home. Fifthly, after making the ground connection, double-check all connections to ensure that they are tight and secure. Loose connections can create resistance and compromise the effectiveness of the grounding system. Sixthly, use a multimeter to test the continuity of the ground connection. Set the multimeter to the continuity setting and place one probe on the appliance's ground wire and the other probe on a known good ground point, such as the grounding busbar in the service panel. The multimeter should indicate continuity, confirming that the ground connection is properly established. Seventhly, after verifying the ground connection, carefully reassemble any parts of the appliance that you disassembled during the grounding process. Ensure that all screws and fasteners are tightened securely. Eighthly, turn the power back onto the appliance at the breaker panel. Observe the appliance for any signs of malfunction or unusual behavior. If everything seems normal, the grounding process is complete. Ninthly, periodically inspect the ground connection to ensure that it remains secure and free from corrosion. Grounding connections can loosen over time due to vibration or environmental factors. Tenthly, it is important to remember that electrical work can be dangerous, and if you are not comfortable performing these steps yourself, it is always best to consult with a qualified electrician. An electrician can assess your home's electrical system and ensure that the appliance is properly grounded according to local electrical codes. Code compliance: always adhere to local electrical codes and regulations when performing any electrical work. Electrical codes are designed to ensure the safety of people and property. Use of correct materials. Use only approved electrical connectors, clamps, and wiring for grounding purposes. Avoid using materials that are not designed for electrical applications. Ground fault circuit interrupter protection. Consider installing a ground fault circuit interrupter outlet for the appliance to provide an additional layer of protection against electrical shock. Testing ground fault circuit interrupters. Regularly test ground fault circuit interrupters to ensure that they are functioning properly. If a ground fault circuit interrupter trips frequently, it could indicate a problem with the appliance or the electrical circuit. Grounding multiple appliances. When grounding multiple appliances, ensure that each appliance has its own dedicated ground wire connected to the grounding system. Avoid daisy chaining ground wires from one appliance to another. Aluminum wiring. If your home has aluminum wiring, take extra precautions when making ground connections. Aluminum wiring can corrode over time, which can compromise the effectiveness of the grounding system. Use antioxidant compounds. Apply an antioxidant compound to the aluminum wiring before making connections to prevent corrosion. Consult a qualified electrician. It is always best to consult with a qualified electrician when working with aluminum wiring. They have the knowledge and experience to ensure that the connections are made safely and properly. Uninterruptible power supply considerations. If the Autovolt appliance is critical and requires uninterrupted power, consider using an uninterruptible power supply. An uninterruptible power supply can provide backup power in the event of a power outage. Sizing the uninterruptible power supply correctly to meet the power requirements of the appliance. Professional installation. Consider having a qualified electrician install the uninterruptible power supply to ensure that it is properly connected to the electrical system. Surge protection devices. Install surge protection devices to protect the appliance from voltage spikes and surges. Surge protection devices can help to extend the life of the appliance and prevent damage from electrical disturbances. Regularly inspect surge protection devices to ensure that they are functioning properly. Replacing surge protection devices when they expire or become damaged. Maintaining cleanliness. Keep the appliance and its surroundings clean and free from dust and debris. Dust and debris can accumulate and create a fire hazard. Regularly clean the appliance with a damp cloth, avoiding harsh chemicals or abrasive cleaners that could damage the appliance. Ventilation considerations. Ensure that the appliance has adequate ventilation to prevent overheating. Overheating can damage the appliance and create a fire hazard. Do not block the ventilation openings of the appliance. Providing adequate airflow. Ensure that the appliance is located in a well-ventilated area. Checking for overheating. Regularly check the appliance for signs of overheating, such as excessive heat or unusual odors. Environmental factors. Consider the environmental conditions in which the appliance is used. Extreme temperatures or humidity can affect the performance and safety of the appliance. Avoiding extreme conditions. Avoid using the appliance in extreme temperatures or humidity. Protecting from moisture. Protect the appliance from moisture and water damage. Compliance with safety standards. Ensure that the appliance complies with all applicable safety standards. Safety standards are designed to ensure that the appliance is safe to use. Checking for certifications. Look for certifications from recognized testing laboratories. Reporting safety concerns. Report any safety concerns or issues with the appliance to the manufacturer or a qualified electrician. Timely repairs. Address any repairs or maintenance needs promptly to prevent further damage or safety hazards. Following manufacturer's recommendations. Follow the manufacturer's recommendations for maintenance and repairs. Avoiding unauthorized modifications. Avoid making any unauthorized modifications to the appliance. Documenting maintenance. Keep a record of all maintenance and repairs performed on the appliance. Proper grounding is not merely a recommendation, it's a fundamental safety requirement outlined in the National Electrical Code, particularly Article 250. Grounding creates a low impedance path for fault currents, allowing circuit breakers to trip quickly and prevent dangerous voltage levels from persisting on metal parts of appliances. The NEC specifies acceptable methods for grounding, including the use of grounding electrodes such as rods, pipes, and plates, as well as the use of the metal water pipe system or building steel as grounding conductors. The size of the grounding conductor is determined by the size of the overcurrent protection device in the circuit, as outlined in NEC Table 250.122. Proper bonding of metal enclosures and equipment is also crucial to ensure a continuous ground path. Bonding involves connecting all non-current carrying metal parts of the electrical system together to create a common ground potential. This helps to prevent voltage differences between metal parts, which can be a shock hazard. The NEC provides detailed requirements for bonding in Article 250, including the use of bonding jumpers and proper connection methods. Ground fault circuit interrupters are another essential safety device that can provide additional protection against electrical shock. Ground fault circuit interrupters are designed to detect even small amounts of current leakage to ground and quickly trip the circuit, preventing a potentially lethal shock. Ground fault circuit interrupters are commonly required in wet locations such as bathrooms, kitchens, and outdoor areas, as well as in other areas where there is a high risk of electrical shock. The NEC specifies the requirements for ground fault circuit interrupters protection in Article 210.8. When working with electrical systems, it's important to use appropriate personal protective equipment, such as insulated gloves and safety glasses. Electrical work can be dangerous, and it's important to take precautions to protect yourself from injury. Insulated gloves can protect you from electrical shock, while safety glasses can protect your eyes from arc flash and other hazards. It's also important to use properly insulated tools when working with electrical systems. Non-contact voltage testers are a valuable tool for verifying that circuits are de-energized before working on them. These testers can detect the presence of voltage without requiring physical contact with the wires, reducing the risk of electrical shock. Before working on any electrical circuit, it's important to use a non-contact voltage tester to verify that the circuit is de-energized. If the tester indicates the presence of voltage, do not proceed with the work until the circuit is properly de-energized. In addition to grounding, bonding, and ground fault circuit interrupters protection, surge protection is another important aspect to electrical safety. Surge protection devices can help to protect electronic equipment from damage caused by voltage surges and spikes. Voltage surges can be caused by lightning strikes, power grid switching, and other events. Surge protection devices work by diverting excess voltage to ground, preventing it from reaching sensitive electronic equipment. It's important to choose surge protection devices that are properly rated for the voltage and current of the electrical system. Surge protection devices should be installed at the service entrance of the building, as well as at individual outlets where sensitive electronic equipment is connected. Regular inspection and maintenance of electrical systems is essential to ensure continued safety. Electrical systems should be inspected periodically by a qualified electrician to identify any potential hazards or problems. Maintenance tasks such as tightening connections, replacing damaged wiring, and testing ground fault circuit interrupters should be performed regularly to prevent electrical accidents. The NEC recommends that electrical systems be inspected at least every 3 years. Changes to the National Electrical Code are made every 3 years to address new technologies, safety concerns, and other issues. It's important to stay up to date in the latest changes to the NEC to ensure that your electrical systems are in compliance with current standards. Local electrical codes may also have additional requirements that are not covered in the NEC. It's important to consult with your local building department to determine the specific electrical code requirements in your area. Remember, working with electricity can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. An electrician can provide expert advice and ensure that your electrical systems are safe and in compliance with all applicable codes and regulations. Here are some common misconceptions about grounding. Firstly, that grounding is only necessary for sensitive electronic equipment. Grounding is essential for all electrical equipment, not just sensitive electronics. It provides a path for fault current to return to the source, preventing electrical shock hazards. Secondly, that a 3-prong outlet is always properly grounded. A 3-prong outlet only provides a ground connection if it is properly wired and connected to a grounding system. It's important to test three-prong outlets to ensure that they are properly grounded. Thirdly, that ground fault circuit interrupters protection eliminates the need for grounding. Ground fault circuit interrupters protection provides additional protection against electrical shock, but it does not eliminate the need for grounding. Grounding provides a path for fault current to return to the source, while ground fault circuit interrupters protection detects and interrupts current leakage to ground. Fourthly, that surge protection is a substitute for grounding. Surge protection devices protect against voltage surges, but they do not provide grounding. Grounding provides a path for fault current to return to the source, preventing electrical shock hazards.